It's a joy to be part of SAHC's virtual June Jamboree and to share the wonders of the late June and July night skies, as well as some upcoming astronomical events. Observing our night sky on a clear night is something that you can enjoy even in the midst of a pandemic. It's best to seek a location away from outdoor lighting and the congestion of buildings in order to enjoy a darker, unobstructed view of the stars and planets on these warmer summer evenings. During this brief presentation, I hope to share what the upcoming summer solstice means to us here in Asheville, the sun's position on June 20th, and the reason that the solstice occurs. We'll discuss the Earth's arrival at its farthest orbital position from the sun on July 4th, something astronomers call Aphelion. We'll take a look at the zodiac constellation Leo, the lion, that is visible in early evening skies in June and in early July. We will learn about the wonderful arrival into our night sky this July of the two gas giant planets, Jupiter and Saturn. And lastly, we will talk about the dog days of summer. The Northern Hemisphere's summer solstice occurs on Saturday, June 20th at 12:43 p.m. Eastern Daylight Time. This marks the beginning of summer in the Northern Hemisphere, but it's the start of winter in the Southern Hemisphere. It's the longest day and the shortest night of the year in the Northern Hemisphere. But why are we having this summer solstice? It's primarily about something called axial tilt. Instead of being tipped upright, that is perpendicular, in relation to the direction of its orbit about the sun, the Earth's rotation axis is tipped over at an angle of 23.5 degrees. This 23.5 degree axial tilt, along with the Earth's annual orbital motion about our sun, are what cause the seasons. We need both conditions for seasonal changes on Earth: a tilted axis and an orbital motion about the sun. Now, this axial tilt is not unique to Earth. All the planets are tilted to varying degrees. Astronomers believe that the axial tilts of the planets occurred because of interactions with other solar system bodies in the early formation of the solar system billions of years ago. The Earth's northern hemisphere is tipped directly at the sun on June 20th, while the southern hemisphere is tipped away from the sun. 6 months later, around December 20th, when the northern hemisphere's winter solstice occurs, just the opposite is true. So whatever hemisphere is tilted toward the sun will experience summer with its longer, hotter days, and the other hemisphere will experience winter with its shorter, colder days. All of us have heard the expression that the sun rises in the east and sets in the west. Do you realize that this is only true on a few days each year around the spring and fall equinoxes? The image on this slide shows you how the sunrise position from Asheville changes during the seasons in a cyclical pattern that reaches extremes at the two solstices. The sun's position on the summer solstice here in the Asheville area reaches two extremes in azimuth. The sun rises 30 degrees north of east and sets 30 degrees north of west on the summer solstice, compared to 30 degrees south of east and 30 degrees south of west on the winter solstice. That's a 60-degree azimuth swing over 6 months. During the summer, this causes the sun to take a much longer path across our skies, thereby providing for much longer days. High solar noon is the time when the sun reaches its highest point in our daytime sky. At high solar noon, the sun has completed its morning climb up into our skies, and it is then beginning its afternoon descent toward sunset. Here in Asheville, the sun rises 78 degrees above the horizon at high solar noon on the summer solstice, compared to only 31 degrees above the horizon on the winter solstice. That's a 47-degree altitude swing over 6 months. That 47-degree swing is no coincidence. It's the Earth's 23.5-degree axial tilt times 2. When you combine the longer path that the sun takes across our summer skies and the higher position of the sun in our summer skies, you wind up with a much longer daylight period, with the sun's radiation at a more direct and intense angle. The Earth's orbit about our star is not a circle, but an ellipse. Consequently, during each orbit or year, Earth has a near point and a far point in its orbital path around the Sun. The near point, that astronomers call perihelion, always occurs in early January, and the far point, that astronomers call aphelion, always occurs in early July. This year, aphelion occurs on July 4th, when the Earth is about 94.5 million miles from the Sun. That's about 3 million miles farther from the Sun than at perihelion in January. Although the Earth is farthest from the Sun in early July, we experience our warmest temperatures at this time of the year. This is explained by the fact that the Earth's 23.5-degree axial tilt has a much more significant impact on our temperatures than the small 3.3% difference in our distance from the Sun. I'm going to slip in a little cool science here about Earth's elliptical orbit. Although astronomer Nicholas Copernicus in 1543 properly postulated his famous heliocentric, sun-centered theory of the then-known universe, he erred in believing that the planets moved around the Sun in circular orbits. Johann Kepler later correctly postulated that the planets orbited the Sun in elliptical paths, not circular. That was his first law of planetary motion. He promptly added a second law of planetary motion in 1609, stating that planets, during their orbits about their star, sweep out equal areas in space over equal intervals of time. That means a planet must move faster when it is closest to the Sun and slower when it is farthest from the Sun. Have you noticed any slowdown in your orbital speed on spaceship Earth near July 4th, when we are farthest from the Sun? This exaggerated illustration helps to demonstrate Johann Kepler's second law of planetary motion, that planets, during their orbits about their star, sweep out equal areas in space over equal intervals of time. Stated another way, that planets travel slowest when they are farthest from their star, in our case, the Sun. Next, we will look at the late spring constellation Leo the Lion. Leo is one of the traditional 12 constellations of the zodiac, and it lies along the ecliptic, the path that the sun, moon, and planets generally follow across our skies. Unlike many constellations, Leo's pattern actually looks like its namesake, a lion. As you look up at Leo, combine two fairly bright shapes that you will see in the sky. A sickle, or backwards question mark, that make up the lion's front half, with a triangle of stars that make up the lion's back end. Do you see a lion yet? The brightest star in Leo is named Regulus, originating from Latin and meaning the little king. It is one of the brightest stars in Earth's night sky. While gazing at Royal Regulus, consider that it is 78 light years away, and that the light that you are seeing left it some 78 years ago. Regulus is a blue-white star with a surface temperature twice as hot as our sun, and that, if placed beside our sun, would appear 240 times more luminous than our sun. Although the constellation Leo is now easily visible in our early June night skies, it disappears from our night skies completely in August, when it is blocked by the sun's glare. Because of the Earth's orbital motion about the sun, Leo is on the opposite side of the sun from Earth in August. So the sun is then positioned in the direction of the constellation Leo. That's the astronomical origin of the astrological concept of sun signs. Leo is my sun sign. What zodiac constellation was the sun blocking when you were born? This slide provides a more panoramic view of the position of the constellation Leo in the late June night skies. Notice how the star Regulus is located very near the ecliptic, the path that the sun, moon, and planets generally follow across our skies. At this position, Regulus is involved with many striking juxtapositions with the moon and the planets. Notice the constellation Virgo with its very bright star Spica, also located along the ecliptic to the upper left of Leo. Although there are no planets visible in the early night sky during late June, that changes with a bang in July. The two largest planets of our solar system, the gas giants Jupiter and Saturn, both come into opposition in July, putting them into prime nighttime viewing for several months. Jupiter comes into opposition first on July 14th. On that day, the Earth, with its inside orbital lane, will pass between the Sun and Jupiter, placing us closest to the gas giant of the year. Rising at dusk and setting at dawn, the planet Jupiter is visible along with Saturn all night during the month of July. Located in the constellation Sagittarius, Jupiter is positioned some 385 million miles, or 35 light minutes, away from Earth at opposition on July 14th. Jupiter is less than half as far from us as Saturn in July, and it also shines some 13 times brighter than Saturn in our night sky this month. During July, Jupiter will be the brightest planet in the evening sky, brighter than any visible star. Jupiter is not only the largest planet of our solar system, but the fastest spinning planet, completing a rotation in just under 10 hours. Its striking cloud-top bands and 4 bright Galilean moons are easy objects to observe with a small telescope. With steady clear skies, Jupiter's great red spot, if it is rotated toward Earth at the time, may be observed in a telescope as well. The planet Saturn comes into opposition on July 20th, about 1 week after Jupiter's opposition. On that day, the Earth, with its inside orbital lane, will pass between the Sun and Saturn, placing us closest for the year to our solar system's Lord of the Rings. Rising at dusk and setting at dawn, the planet Saturn is visible along with Jupiter all night during the month of July. This slide shows you the view looking southeast about 9:30 p.m. Eastern Daylight Time on July 25th. Both Saturn and Jupiter are positioned in the constellation Sagittarius the Archer. Saturn is located some 836 million miles, or 75 light minutes, away from Earth at opposition on July 20th. Jupiter is less than half as far from us as Saturn in July, and it also shines some 13 times brighter than Saturn in our night sky this month. Like Jupiter, Saturn is a fast rotator with only a 10.7-hour day. But its orbit about the Sun takes 29.5 Earth years. Its planetary disk is about 75,000 miles in diameter, but its ring system is some 175,000 miles across, with an average thickness of only 10 meters. Saturn's striking ring system and the 4 brightest of its 82 moons are easy objects to observe with a small telescope. Over a few nights at the end of July and the beginning of August, the waxing gibbous moon will glide along the ecliptic and pass the planets Jupiter and Saturn. Go out just after dark and enjoy this wonderful juxtaposition of some bright solar system bodies in the southeast skies. We often hear about the dog days of summer, but few know what the expression means. Some say it signifies hot, sultry days, not fit for a dog. Others suggest it's the weather in which dogs go mad. The dog days of summer describes the most oppressive period of summer between July 8th and August 17th each year. But where did the term come from, and what does it have to do with dogs? The phrase is actually a reference to the fact that during this time, the Sun occupies the same region of the sky as Sirius, the brightest star visible from any part of Earth and part of the constellation Canis Major, the Greater Dog. This is why Sirius is sometimes called the Dog Star. In summer, Sirius rises and sets with the Sun. On July 28th specifically, It is in conjunction with the sun, and because the star is so bright, the ancient Romans incorrectly believed it actually gave off heat and added to the sun's warmth, accounting for the long stretch of sultry weather. Thus the term dog days of summer came to mean the 20 days before and the 20 days after this alignment of Sirius with the sun, from July 8th to August 17th. If you are interested in learning more about our night skies, consider downloading the Sky Safari app to your smartphone or tablet. Or if you prefer a printed seasonal star chart, find some free and very useful ones at the What's Out Tonight website. Most of the information that I just presented and shared with you is already posted on the website homepage and Sky Events page of the Astronomy Club of Asheville, www.astroasheville.org. This website is a great resource for what is happening in the night skies over our region. With that, I want to say thank you for sharing this journey with me for some of the highlights of our late June and July night skies.